Let's take our next question, that is question number 22. As per the question, magnetic field at point P due to finite length solenoid of n turns per unit length, where angle at P subtended by the two ends is pi by 6 and pi by 4 as shown. So it's a pretty simple formula based question. Let's start the solution. As per the formula, it is mu naught small n, number of turns per unit length, divided by 2 cos of phi 1 plus cos of phi 2. So we know what is the value of phi 1, that is 30 and 45. Let's put down the values. So B is equals to mu naught Ni by 2. This is cos of 30 degree plus here is cos of 45 degree, right? When you solve this, you will get B is equals to mu naught Ni upon 4 into root 3 plus root 2. Let's see which is the best suited option for the same. So if you can see, out of the 4 options, option number 1 is the correct answer for same. Now let's move on to our next question, that is question number 23. As you can see in this case, there are two hollow core solenoids A and B are connected by a wire and separated by large distance as shown in the diagram. Two bar magnets 1 and 2 are suspended just above the solenoids. If the magnet 1 is dropped through the solenoid A as shown, then the magnet 2 will simultaneously be. So first of all, it's basically Faraday's law. If north pole is coming towards it, this will develop a north pole. Now let's get a top view of the same. If this is the core and north pole will be developed like this in it, that means the current is flowing like this. So current will be in this direction for the solenoid. This current will go here. So if you see the top view of this as well, the current will be in this direction. That means it is also forming north pole. So here north pole will be formed and south pole here. So that means there will be some attraction. Let's see which is the best suited option. First, attracted by a magnetic force towards the solenoid B. This seems to be correct. Let's see the second one. Repelled by a magnetic force away from solenoid B. No. Repelled by an electric force away from solenoid B. No. Unaffected by solenoid. No. So correct answer to this question would be option number 1. I hope you have understood the question. Now let's move on to next question. Now here in this question you see a series of LCR branch is connected across an alternating voltage generator of frequency F. Current in the branch leads the voltage by 37 degrees. That means capacitive reactance is better or greater than the inductive part. If C and R are the capacitance of capacitor and resistance of resistor, we have to find the inductive reactance of the circuit, right? It's given that tan phi would be equal to VC minus VL by VR, or I would write XC minus XL by R. Now this phi is given to us as 37 degree and tan 37 would be simply 3 by 4. That is equals to, for XC I can write 1 upon 2 pi F into C, that is 1 upon omega C, minus XL and whole divided by R. When we simplify this, we will get XL as 2 minus 3 pi FRC divided by 4 pi FC. So let's see which is the best suited option. Among the 4 options given to us, option number 1 seems to be the correct answer. Now let's move on to the next question, that is question number 25. So friends, we have reached to the last question of the segment. Let's see. An electron of mass m, charge minus q, enters a region of uniform magnetic field at point 0, 0. You have to be cautious, this is an electron. Now the field region is from x equals to 0 to x equals to 2 mv by bq, and in y-axis it is extending from minus infinity to plus infinity. The y coordinate of the particle when it emerges out of the magnetic field will be, it's an easy and simple question. First is the extent to which the magnetic field is. So let's suppose magnetic field is till this point and this distance is equals to 2 mv by bq, which is actually twice the radius of the particle. So it's not possible for the electron to move out of this magnetic field. Certainly it will form a semicircle and will come out from this region. And what would be the distance? Definitely, since it's a semicircle, it would be 2r. So as per the solution, if you see, it will come out at a distance of 2r, which is equals to 2mv by bq, since it is performing the semicircular motion. Why it is coming down? Since the magnetic field is inside, so magnetic field, what about the current? Since electron is moving in this direction, current will be in opposite direction, so force will be downwards. That wise it is coming in this direction. So this is coming towards minus y-axis, so I would write minus and minus. So let's see which is the best suited option among the four. Yes, option number 3 is the correct answer. So I hope you have understood the question very well, and all the best for the results. Thank you so much.